Welcome to Conservation Biology Week 1. Conservation biology is a field of study that applies ecology, geography, population genetics, economics, sociology, anthropology, philosophy, and other theoretically based disciplines. There are three important distinctions. Conservation biology includes and has been led by major contributions from theoretically oriented academicians. Previous motivation was largely to maintain high yields of desired products, such as forest products or timber. It recognizes and embraces the contributions of non-biologists. The goal of conservation biology is an understanding of natural ecosystems well enough to maintain their diversity in the face of known and unknown threats. For example, intelligent and informed management decisions. It's to maintain biodiversity, and that means genetically, population diversity, species, habitats, ecosystems, landscapes, and ecological processes. In other words, natural selection, biogeochemical cycling, photosynthesis, energy transfer, and hydrologic cycles. Conservation in the United States compared to European landscapes, North America was relatively pristine. However, many extinctions had already occurred, reducing the megafauna diversity. Early colonists cleared extensively the eastern hardwood forests for timber and agriculture. Later, forests were exploited again for railroads and buildings, and after several hundred years, the concept of conservation biology began to emerge. Romantic transcendental conservation is an ethic based on the writings of Emerson and Thoreau in the 1850s, whereby nature had a quasi-religious aspect, and then later John Muir used this argument to establish the national park system. The resource conservation ethic was popularized by Gifford Pinchot at the turn of the 20th century. Gifford Pinchot is known as the father of forestry. The greatest good for the greatest number for the longest time is that ethic. Nature was a combination of useful, useless, and noxious items, and the Forest Service and BLM came under the multiple use concept that this expresses. The land ethic, which is based on evolution and ecology, goes back to Aldo Leopold, although trained in the resource-based conservation aspects of it, saw it as inadequate and scientifically inaccurate. And the development of ecology and evolution demonstrated that non-randomness of processes and patterns. Aldo Leopold was known as the father of wildlife management. Each of these three views is evident in these various organizations of today, such as the Forest Service, the Sierra Club, and the Nature Conservancy. Current conservation efforts represent a more balanced view than the extremes of these three views. In the early 1980s, many edited books were published that demonstrated the loss of biodiversity and habitat. In 1985, the Society for Conservation Biology was formed and established the Journal of Conservation Biology, and many universities have established conservation biology majors and graduate programs. The guiding principles of conservation biology are: 1, evolution is the basic axiom that unites all biology. The ecological world is dynamic and largely non-equilibrial. And 3, human presence must be included in conservation planning. Conservation biology must take evolution into account when trying to develop solutions to ecological problems. For example, genetic composition of populations is dynamic, thus it is not the goal to stop the change, but rather ensure that they have the ability to change and adapt. The ecological world is dynamic and largely non-equilibrial. If the world were in equilibrium and static, conservation biology would be easy. At some spatial or temporal scale, all systems become dynamic. So think of an ecosystem and then think of a natural disturbance. Principle 3, human presence must be included in conservation planning. Any conservation efforts that do not account for humans, either as the cause of the problem or part of the solution, are doomed to fail. The benefits of acknowledging people is that we can incorporate indigenous knowledge. Those are as of the Native Americans and tribes and various native peoples. Second, areas must be user-friendly. Some will have limited multiple use, and we can also educate users on the scientific rationale of why uses are limited. And third, Aboriginal people have a right to their traditional lands. E.O. Wilson is a famous ecologist, and these are his 4 postulates. Diversity of organisms is good, ecological complexity is good, evolution is good, and biotic diversity has intrinsic value. Some aspects of conservation biology: it's a discipline responding to an immense crisis. Information is frequently incomplete and sometimes missing. Typically, an issue is politically or economically charged, and we are asked to provide quick, clear, unambiguous, and scientifically defensible solutions. Is this realistic, and is it possible? This chart is a Venn diagram which shows the overlap between the different aspects that create conservation biology: the natural sciences, the social sciences and humanities, and then the combination of those with the list of things that are shown under conservation biology. Conservation biology is an inexact science. The nature of an ecological system is that it's complex and variable, and uncertainty is inherently part of ecology and conservation, and probabilistic rather than prescriptive answers to problems are the norm. Consequently, conservation biology scientists rely largely on quantitative approaches. Unfortunately, that can result in a credibility gap. Simple ecosystems are incredibly complex. Consequently, conservation biology should think in terms of the precautionary principle, which is first, do no harm. Conservation biology is a value-laden science. Science is value-free. Should scientists lend their expertise to the debate is a question, whatever that science is. However, objectivity should never be compromised or all credibility is lost. And traditional resource management typically attempts to maximize the current yield. Think North Atlantic fisheries, think forest production. So there is an evolutionary timescale to conservation biology, but our traditional resource management is not set up with that in mind. The goal is to simply retain the diversity of structure and function forever. It is also a science of eternal vigilance. Even protected areas may not remain protected. And think about the Alaska Wildlife Refuge oil debate and whether it will be tapped or explored for oil rather than remain off limits. And then there are expanding human demands. Why is the environment in such trouble? Simply the collective impact of 6 billion plus people and their desire to live a good life on the planet. And here's the problem we see over time: the population in billions. Here is some information about how many hectares per person are needed to support our current lifestyle. And you can see the UK versus US, and then look at India and Tanzania. So humans continue to co-opt more and more of the world's primary productivity. 35% of ocean shelf and 60% of freshwater production are used by humans. Overall, somewhere between 20 to 32% of primary productivity is being used. The ecological footprint is not equal across countries or within countries. And here is a map to show about how wild areas are, less wild versus less influence. The whiter areas being those that are impacted the least, and the darker the ones that are impacted the most by human presence. Remember, humans are part of the problem. We're also part of the solution. And this is an optimistic view, but if we look at the world's growth rate, it is slowing, and education is important in that, and that we can change our consumption patterns. And if you consider the US and Germany or the UK, there are a lot of examples of changing use patterns. So biodiversity, a little bit about that. The diversity of life on Earth, there's variety at all levels of biological organization. There's genetic diversity, species diversity, diversity among higher taxa, ecosystem diversity. All different components of it. Are different groups of organisms equally diverse? Are different parts of the world equally diverse? Scientists estimate between 150 and 200 species of life become extinct every 24 hours. The mass extinction is due in part to humans' unsustainable methods of production and consumption. More than 60% of the world's people directly depend on plants for their medicines. About 12% of mammal species and 11% of birds were classified as threatened in 1990. According to the World Resource Institute, the biggest cause of extinction is loss of habitat, and there are as many as 100 million species on Earth, of which 1.7 million have been identified. And here are some references that you might find useful to find out more about conservation biology. And here are the web resources used to prepare these lecture notes.